Welcome back to my channel. Today we are going to see how to plot an analog signal. So in the last lecture, we had seen like basic elements of digital signal processing. There we saw like we'll be usually dealing with analog or digital signal in any real-time scenario. So in order to process any analog signal or digital signal, there are various computer tools which are available like Matlab, Octave, or even Python we can use. So in my lectures, I usually show how you can deal with Octave or Matlab and even like Python based coding. So today we will see like how we can plot an analog signal in Matlab. So before we start like the Matlab coding, we first will understand some basic things about analog. Okay, so here, like let me consider a simple example of sinusoidal wave. This continuous wave or analog wave. So whenever we take this kind of sinusoidal wave, so we will have two axes: x-axis that will be usually time, and y-axis. Now x of t is now it is sine t. Okay. So now what we will be doing is basically first we need to define time axis, right? So we need to define time axis, which basically tells like from what range to what range we need to plot. If I consider like this is like 0 and this may be like here it is 1 second and this is 2 seconds, right? So I need to plot from 0 to 2 seconds. So usually in MATLAB, since we are dealing with computer programs, computers usually are discrete in nature. Like it will not understand continuous waveforms, right? Like maybe olden days cathode ray oscilloscope might have understanding that like kind of continuous wave. But here will not be like this MATLAB or like any software tools will not understand a continuous wave. So we need to discretize this. So we should say that like I need to have so like during analog signal processing always take step which are like very small in nature. So here I will take in steps of 0.001 second. In the sense, I will have various points, but it is not continuous because like your computer will not understand. So what I will be doing, I'll be I mean, I'll be defining the values in steps of 0.001 second. Like it is like sine 0 here, sine 0.001, sine 0.002, and so on, and up to 2 seconds. Okay. So let's see how we can put that condition in the MATLAB. So we have to define a variable called t. It's time axis. So my time will start at 0 and it will end at 2. This is in seconds, right? So by default, if you give this command, right? So we can see like if I give just this command, so like by default the steps will be taken as 1 second. So 0, 1, 2, 3 points are created. But according to the condition, I said like for the analog we have to create a very small steps, right? So in that scenario, for like I said, like we will take 0.001, which is like very small value of time. So in that sense, like we have to create a step in this way. Zero, what should be the step? That is 0.001 is my step, and till what 2 is my end point, right? So this is starting point. What is the increment and till what point? If you see here, like 0.001 times increment of each points are created. So you can see like what is the length of LENGTH. So length of like T, you can see like there are 2001 such points are created, right? So it is like very small points of these sinusoidal waves are created. So now we created time axis. Okay, so now we'll see how we can create actual waveform, like the continuous waveform or an analog waveform, how we can plot the analog waveform in MATLAB. So we need to know some of the properties of sine wave. So when we decide or like when we design a sine wave, uh, first we need to know what are the properties of a sine wave, right? So usually the sine wave f of t will be represented as amplitude A into sine 2 into pi pi frequency. So what is the frequency of pi f t? So here, let me assume my frequency is of 1 hertz, right? So when I say my frequency is 1 hertz, we know the period that is like 1, like from where the instance that occur and like repeats. So we know that from here it repeats, the sine wave repeats. So this is like 1 by f, that is 1 second, right? So we know that like from the MATLAB we saw we are plotting from 0 to 2 seconds. So we need to have two repetition of sine wave, right? So like this also will be second. So we'll have two repetition of like a same wave. So like t is 1 second. So we will take f as 1 hertz and t is the values what you have generated from the MATLAB like 0 to with the increment of 0.001 second and like up to 2 seconds. And we know that this 2 pi is like constant, like 2 into 3.14. So we will see how we can like this is the wave what we will be generating and it is something like this. So each value of t, right? So it will be generating like initially let me consider amplitude as 1. Okay, my maximum will be like between plus 1 volts to minus 1 volt. So my amplitude will be fluctuating between these. So with that assumptions, my this equation will be like simplified into 1 in sine 2 into pi, that is f is 1 hertz, is 1 hertz into t. So for each value of t, we will get f of t. Like initially, my value will be like we know f of 0, then it will be f of 0.001 and f of 0.02, so on up to f of. In this way, it will be plotted, right? So like you want to see how it will be plotted. So we know that like sine 0 is 0. And then like it will be plotted sine 0.01, 0.002, and it will go to the point at point 0.5, like at 0.25 will be sine pi by 2, right? So it will go to the maximum and eventually it will go down and such two way will be repeated. So see now one thing you should notice here. So, like, even though I'm saying analog signal, computer will not understand analog, right? So it has to be discrete because, like here, if you see, not continuous wave. I'm actually like marking the points which are all discrete in nature, right? But anyway, like just by differentiating the plotting itself, we can represent certain wave as analog or discrete wave. Okay, so it's just a difference in a plotting. Okay, so we will see like how we can do it in the MATLAB now. So previously we had seen how to generate t. Now we have to generate the amplitude. Okay, so I will take amplitude value as f. f of like f underscore t, that is like function of t. So we know that like it has to be actually like the waveform has to be a into capital A into sine 2 into pi. Like pi is a variable, it's a constant which is already available in the MATLAB, so we not explicitly declare. And pi 2 pi f into t. Here if you see, we have already defined t frequency. I told that like let's consider it as 1 hertz, and a is like kind of like 1 volts. I said like we'll consider 1 volt, but we haven't declared it, right? So those values haven't declared it. So if I give enter, so it will say that like a and f is fine, so you get that error. The unrecognized variable a. So we need to define a and f, right? So let me define a as 1 volt and f as 1 hertz, right? So now let me put same equation. Now f underscore t equals to a into sine 2 pi f t, right? So now again, if you see like the values are generated for f underscore t. So if you see length of f underscore t, it's basically 2001 points. And like previously we had seen that like there are 2001 t values, right? So for that discrete 2001 points of sine values are generated. Now next question is like how we can plot this, right? So it's a for plotting, it's a simple command, plot f underscore t with respect to what I need to plot, right? I need to plot with respect to t, right? So yes. So if you see, it's like it's reversed way, right? So it's not right way. So if you see here, like we interchange the argument, right? So it has to be first initially we have usually we plot x comma y, right? So here x axis is t and y axis is f underscore. So you have to type that. To type it, you're going to get this particular waveform, right? So you can see that like two like if you see here like two different two cycles of waveforms, right? This is what we wanted. But like if you see like usually when we plot a certain graph, we need to have both like x axis and y axis, right? Like we need to represent that x axis explicitly. So we have a command called x label. X label, I'll say it as a t in the code we have, and y label, I'll say it is f of t, or you can mention it as a sine phi f t. Now if you see here, you can see x label is mentioned as t and y label is like f of t. This is how we plot a sinusoidal wave. Like I mean in general how we plot analog wave. So actually one thing you should keep in mind whenever we are plotting any analog wave in the MATLAB, it's actually discrete in nature. It's not actually an actual analog wave what you get in real time. Maybe like if you measure certain waveform in like golden cathode ray oscilloscope, you might see that continuous wave, finitely small time differences. But here what you are saying is like completely discrete in nature, but it appears as analog. That being a DSP engineer, that you should keep it in. Okay. Thank you. In next lecture, we are going to see like how we can plot, how like especially like it's basically we are plotting discrete itself here also, but in that lecture we will see how we can represent a discrete way, discrete form, right? So usually whenever you want to do some analysis, how you can represent that, that we are going to. Thank you. Thanks again.